Hi, I am Akshat Swalka, a fourth year student of Mechanical Department from IIT Kharagpur. My BTP project was based on classification of the eye in AM/PM. This project was done under the supervision of Professor Pabitra Mitra from CSE department. It is a computer vision project based on the deep learning model. I had given a raw data of the retinal image of the eye from Heidelberg University from Germany. As you can see that the image of the retinal image of the eye. So basically I want to classify that given an input image of retinal image of eye into whether it is an AM or slash PM. AM it is before midday and PM after the midday. So we are using the deep learning models and deep learning techniques to classify the image. After experimenting a lot and seeing the research of the people, I came to conclusion that actually this particular part of the retinal image is important and used for classification. So what I had done, I basically cropped that particular part of an image and use in my uh, deep learning models. As you can see that now the image is cropped. So now moving further, as you can see the images are cropped. And yeah, so actually the images are like some images are taken before AM, so they are categorized as AM, and the images that are taken after 12 AM are categorized as PM. So the images are taken of some time gap, like here you can see 2.5 minutes, then after 5 minutes, and 5.5 minutes, then 6 minutes. So seeing such type of time series data, the first thing that comes in our mind is that we should use RNN architecture, recurrent neural network, basically, and specifically we should use some CNN RNN networks, like because it is an image. RNN are used for some language and some text particular things, and because if we are given an image data, so we have to use CNN, and then we should use RNN. So in particularly that we should be focused on CNN LSTM. LSTM is basically a RNN architecture. Now let's see different types of RNN architecture. Specifically, we are main focus on CNN LSTM, as LSTM is a part of RNN, so we can have this multiple CNN LSTM architecture. So there is one-to-one architecture, one-to-many architecture, many-to-one architecture, and many-to-many. Uh, for our project, for our problem statement, we are using many to one. Why? See, like we have this timestamp images here, and we are given this as an input to our deep learning model, and it is given an output, like whether it is an AM or PM image. Now let's see more sophisticated architecture. So you can see like here we are giving the series of an retinal images as an input to first our CNN architecture, and after getting the features from CNN architecture, we are passing into an LSTM. So here you can see the other images also, they are all passing through CNN one by one, and then we are getting their features in an LSTM part, and then after LSTM it is now passing for encoding, and then we have this final fully connected network as a dense network here, and then it is used for basically classification whether the image is in of AM or PM. So similar architecture is given here also. So you see, like here we have a sequence of data of various timestamps, and that is taken as an input. Not a single image is taken as an input, but some like 2.5, 3.5, 4.5, 5.5. Some timestamp images, group of timestamp images are taken as a single input, and then they are passing from CNN and getting their features, embedded features, and then after that they are passing through LSTMs, and after a series of LSTM they are then encoding, and then we have this fully connected neural network, and we are classifying whether it is an AM or PM. Implementing the whole architecture in the code in basically in TensorFlow, like it takes nearly a 1 month for me, like writing from scratch. I have provided the link of my code also in the last page of PPT, you can see there. So after implementing and training the whole architecture, like we got a very poor accuracy, like nearly 66.67%, because for a binary classification, it is not considered as a good accuracy. And the reason of getting this poor accuracy is the lack of sufficient data. So actually, I had got only 300 to 400 images of this data, and you see, like LSTM is a huge network, and it requires lots of training, and for lots of training, it requires lots of data. So just by 300, 400 images, it is actually obvious to come such a poor accuracy, and using the CNN make it more expensive for training, and that's why poor accuracy I got. Then my supervisor, Professor Pabitra Mitra, suggested that actually you should implement this data to a pure CNN network, like taken images as independent, and one by one you should give an input to an some densenet or maybe ResNet, and then calculate the classification and get the accuracy. So I followed his instruction and moved on. So I had taken ResNet networks and different variants of ResNet networks and some other architecture, VG16 and all other networks, and finally DenseNet 121 networks and its other variants also. And I found that actually for this particular data set, like DenseNet 121 is the best one. So what is DenseNet 121? So basically, it is similar to ResNet one, and normal CNN architecture, what happens that the activation of current node is calculated by its just previous node. But what happens in DenseNet architecture, we first divide into some dense blocks. Like here we have this dense block 1, dense block 2, dense block 3. And in each dense block, what happens? The activation of this node is calculated by the activation of all its previous nodes in a particular block. So activation of this node is calculated by this one, then this one, and this one also, and this one also. So gathering the information of all previous nodes, we are calculating the activation of this particular node. So similar thing happens for this particular node also. For calculation of this activation, we use this one, uh, and we use this one, and we use this one. So similar technique and strategies used for other dense block 2 also, like in dense block 2 and dense block 3. And between we have this one convolution and one pooling. And finally, we have this one fully connected network, and we are using basically this binary cross entropy loss to classify the given image, whether it is in AM or PM. So after training my data on this particular DenseNet 121 architecture, I got nearly 90.9% accuracy, which is far better than the previous accuracy that I got 66 nearly accuracy. So DenseNet 121 model was successful because we have less amount of data. So to evaluate our model, I use k-fold cross validation. So what is k-fold cross validation? In this, first we shuffle the dataset randomly, and then we split the dataset into k groups. After what, for each unique group, what we do, we take some amount of training data, and the remaining was our test data, and then we fit our model on this particular set of data, and evaluate our test set then, and uh, and then discard the model. And then for other group, we again take some training data, and some remaining was the test data, and evaluate our model on that particular type of ordering of data, and then discard the model. And then again we take the training set in some other order, and evaluate our model on the test data. So we take some k amount of group and evaluate on this k data set. So here are my results of 5 as taken as k. So for fold 1 I get 92.4% accuracy, and for fold 2 90, then 92.7 and 96.6 and 95.7. So like I calculated the confidence metrics of the my last fold in the cross validation also, and it comes that 5 of my input data is predicted as wrong. So it's fine, like I am getting 90 plus percent accuracy. So, and all of my code is available on this links. This present last page of my PPT, and you can verify all my results. And so in fast AI, I implemented CNN and LSTM because like I'm getting poor accuracy, 66% TensorFlow. So and in the fast AI also the same amount, 64% accuracy I'm getting. So I have to that decline that particular model and go for the instant 121, and that I had implemented on fast AI. You can check it out. Thank you.